Okay, final exam review, page 5. Let's have at it. Okay, find the value of the cosine of the triangle shown. Okay, this question is always a trap. Okay, it looks really easy. But the thing you have to realize is that you're not in the unit circle. All right, so what does that mean? That means in the unit circle, you know your radius is 1. In this, your radius here is definitely not 1. Okay, just to clarify, that's the point 3 negative root 5. And, we're looking for this triangle here that we want to construct and try and, use the fact that it's a right triangle, okay, to find the length of the radius, or in this triangle, the hypotenuse. So this is 3, this is negative root 5, and that's the guy we want to find. So using Pythagorean's theorem, okay, we will solve for C. That's 9. 2 negatives make a positive, and the square root of 5 squared is just 5, which is equal to c squared. So c is equal to, just the square root of 14. Okay, so c is equal to the square root of 14. So cosine of this angle theta, okay, is equal to SOHCAHTOA, adjacent. So 3 is adjacent over the hypotenuse, which is 14. Always rationalize your stuff on finals. So maybe I'll take 3 over radical 14 and multiply it by some form of 1. I'll choose root 14 over root 14 and get 3 radical 14 over 14. So therefore, cosine of theta is equal to 3 root 14 over 14. All right, let's see. I bet you it's another one of these. Okay, lots of alpha and secants here. All right, getting kind of crazy. So they told me that cotangent of alpha, I'm just going to use theta, is equal to 8. And they also told me that secant of theta, or alpha, is less than 0. That's a little bit tricky there. Well, the thing about this is we know that secant is the same thing as 1 over cosine of theta. And if we want that to be less than 0, then cosine of theta can't be a negative number. So this is saying that cosine of theta has to be greater than 0. I know it looks strange, but if you just think about it, what values of cosine can this be so that, that it's less than 0? So forget what I just wrote. For this guy to be less than 0, cosine of theta has to be less than 0. Okay, in other words, it has to be negative. So where is cosine negative? It's negative in quadrant 2 and quadrant 3. Okay, so we narrowed it down to 2. The other thing they gave me was cotangent of theta is equal to 8. Let's see. So cotangent, I'll just do it the long way. 1 over tan of theta is equal to 8. So what does that mean? It means tan of theta is equal to 1 over 8. So what's that? So we know that tan of theta is equal to y over x, or SOHCAHTOA, opposite over adjacent. And they're both, looks like they're both positive there. So where can we be? Well, either they're both positive or they're both negative. So the only place that that's going to occur is in the third quadrant. Okay, in other words, 2 negatives make a positive, and everything in the third quadrant are both negative. So in other words, this is the same thing as negative 1 over negative 8. Now, that also occurs in 1, but because of our restriction of 2 or 3, we're forced into quadrant 3. Yeah, one of the tough problems for sure, sorting that all out. Okay, well, good luck with that. And okay, so here we go. We get a negative 1 here for our thetas here, and so that's opposite over adjacent, that's negative 8 here and a negative 1 here. So let's just use Pythagorean's theorem. So that's negative 8 squared plus negative 1 squared is equal to c squared. 64 plus 1 is equal to c squared. So c is equal to the square root of 65, and radiuses can't be negative, so don't worry about that. They want to know what sine, okay, of this angle is, and sine is an opposite SOHCAHTOA, so opposite is -1 over radical 65. Again, they like you to rationalize things, so we'll multiply by radical 65 over radical 65. And finally, we can say sine of theta is equal to negative radical 65 all over 65. There you go. Okay, so yeah, I'll admit it was a little loose there. If you have any questions, just come see me. Okay, let's try 31. 31 says I like to write it like this so I don't get confused. Cosecant of 2. I just like that so you don't think of it as a fraction that's just going to be brought downstairs. Oh, how does this work? So, oh, I don't know. I guess I would say something like cosecant of y is equal to 2. I don't know if you guys are good like that. And then I get sine of y is equal to 1/2. And arcsecant, oh my goodness. So I got to think of what the domain is of that guy. I think, what does he look like? That's tough to figure out his domain. So with that said, I'll just play it safe and start in the quadrant 1. And when is sine equal to 1/2? When is the y guy equal to 1/2? And that happens right here at √3 over 2 comma 1/2. And that angle here, so I'll say y is equal to pi over 6. Okay, I think that was one of the tougher ones I've seen so far. They're all not easy, I guess. Okay, let's just try that same game here. So that means cosine of y is equal to 1/2. That's straight up right there. Again, on the unit circle, where does the 1/2 occur for the x guy? And playing it safe, I'll play in the first quadrant. And I believe that's just pi over 3. Okay, that was 32. Okay, again, a lot of this is just really knowing your unit circle. All right, finally, some action here. Simplify the expression. So 1 over cotangent squared theta plus, let's just undo everything here. I'll just write it out because it's fun. Secant of theta cosine of theta. Okay, off to the races. I guess I could write that as tan squared theta. That's a nice move. Secant is 1 over cosine theta. Are you kidding me? This is cosine theta. Those things are gone. And you're left with tan squared of theta plus 1, which is a trig identity. And I believe it's just secant of theta. So that's a really nice, quick, and easy one. Yep. Is there another one here? Am I finished yet? Is that the last one? All right, last one on page 5, I believe. So simplify. It might go pretty simple. Yeah, that 1 minus sine squared of x. So yeah, so you might want to go and review your trig formulas. You know, the main ones. You know, it doesn't look like they're getting too nasty out here on this review, but you know, you should know the mains when we worked with this year. Sine of x minus cosecant of x. The first one that's staring at us is cosine squared plus sine squared of x. Oh my goodness, it must be getting tired. Is equal to 1. So we know cosine squared. That we know this one pretty well. So I hope that one sticks out. So that's just cosine squared of x over, and then you know you don't have much you can do here. That's 1 over sine of x, so that's a lot of work in your denominator. So I'll just leave the numerator alone, and then I'll get to work down here. So what's that going to be? Sine squared of x minus 1 over sine. I did that quick, honest pre-calc, right? Just common denominator sine of x. It multiply the top and bottom by a sine of x, so that's where that sine of squared x is coming from once I find the common denominator. Yeah, so I'll probably write it like this. So cosine of x over 1 times the reciprocal, which is sine of x. Whoa. Sine squared. No, excuse me. I'm getting tired. I'm doing videos for a couple hours here. Sine of x of sine squared x minus 1. That one looks interesting. It almost looks like this guy. In fact, I can negate this side. And if I negate that side, I get sine squared minus 1. Ooh, nice tricky problem there. So that's equal to cosine squared of x over 1 times sine of x over negative cosine squared of x. Here we go. And yes, it's just simply sine of x. So yeah, you want to be good with your fractions there. And there's a negative on it. Don't forget that negative right there. And I think that's it for this page. And still under 12 minutes, looking like the average is somewhere under 12.